This will be the first of a series of videos that I'll make in which I went to the Hawks course 1110, went to the practice sessions, took screenshots of various practice examples, and then put them in this PDF file. And the purpose of it is to give you some background in practice. So we'll start off with a lesson 1.1. And my advice is pause frequently, look at the example, and then see what you would get. And then I'll go over the protocol to get what I think is the answer. And I'll use these as general review as well. So in item number 1, we're asked to place a negative 22 in which of these categories of real numbers. Now, all the numbers on the number line are real numbers, so this is a real number. Is it a rational number? Yes. Is it a whole number? No. Remember, whole numbers are 0, 1, 2, 3, and so on. Is it a natural number? No. Natural numbers don't include a 0. They're the counting numbers, 1, 2, 3, and so on. Now, is negative 22 an integer? Yes. Is it an irrational number? No, if it's rational, then it's not irrational. Irrational numbers would be the square root of 2. That would be numbers in their decimal form that don't have a repeating pattern or don't terminate. These are things we covered in our flipped classroom lesson. Now in item 2, or example 2, ask us to write this in algebraic terms. So 9 is greater than, so would be this, or equal to, we have to add that, to a negative 11. Now for number 3, as I looked at it, I didn't quite understand what they're asking here, or what they're showing here either. But let's use it as review. I'm going to review each of these properties with you, and then you can see how it matches to what they're asking. All right, the commutative property of multiplication is A times B equals B times A. The commutative property of addition, A plus B equals B plus A. The distributive property, where we have, let's say, A times B plus C becomes AB plus AC. The multiplicative inverse. This is where we have, let's say, A times 1 over A. That is, it's reciprocal, so that the product of this is 1. The additive identity. That is, we can add anything to A that would not change its value. And the only thing we can add that doesn't change its value is 0. So anything plus 0 is still what it was originally. Now the associative property of multiplication, A, B, C equals A, B, B, C. This is an identity. But in the associative property, if we put parentheses around these two and multiply these two first and then the C, we get the same answer as if we multiplied the BC first and then the A. This is the properties of algebra, arithmetic, that allow us to do things and get correct, valid answers. All right, the associative property of addition. Again, the order is the same. A plus B plus C equals A plus B plus C. But here we're adding the A and B first, then the C. And here we're adding the B and C first, and then the A. This is the associative property. Now the multiplicative identity is we can multiply anything by 1 and it's always the same. So notice the difference. The multiplicative identity is multiplying anything by 1. The additive identity is we can add 0 to anything and it doesn't change its value. Now the additive inverse is if we have A and subtract or add a negative A, the answer is 0. So the additive inverse is what we would add to something to make it a 0. Example of this is if we had 5, we would add a negative 5 or its opposite sign to get 0. Now as we look at this up here, here I see the only difference is this is a 9y squared and this is a 7y squared and a 2y squared. Everything else is the same and I don't really see one of these values. So I'm not sure whether this would be a false statement and they're saying that it equals to 0. Again, when you work with the practice, this is to see what they're looking for. And you can go down to the tutorial box if you get it wrong, and then it shows you specifically what they're looking for. Now for number 4, this one is rather clear-cut, and I'll move it up so you can see it. Again, pausing it, taking a look at what they're asking, similar to the previous question, which would match up as you see this here. Well, notice the order is exactly the same. The only thing difference is the grouping. Here we're grouping these, there we're grouping this. So this is the associative property of addition. Now for number 5, again, pause. What are they asking? Well, they're asking us to use interval notation to write this. Right now it's in set builder notation. So because it's only less than, we're going to use a parenthesis for -4, comma, and for the 13, because it's also equal to as well as less than, we use a bracket. All right, number 6, simplify the following union and or intersection. Well, here, this is the symbol for union. This would have been the symbol for intersection. So this set is 1 through 7, and 1 is included. So a bracket, 1. Now, when it gets here, in this set, 7 is not included, but it is included there. So this is a continuous to positive infinity, and infinity always has a parenthesis. All right, for number 7, and I'll clear this up, we're asked to substitute the x with a 2, so 2 plus 2, and then minus 9, y is going to be a 3 that we're going to square. All right, so take a moment and see what you come up with. Well, this is the square root of 4, which is 2, so 6 times 2 is 12, minus 3 squared is 9. Negative 9 times 9 is a negative 81. So this becomes a negative 69. And again, you know, some of you may do this in your head. May want to check it with your calculator if you're not good at computation. Now, for the last item, and again, these are just a few of the kinds of practice that you would get. I tried to pick a sample of them. Here they're asking, select which of these symbols would you put here to make the statement true? Well, these are actually equal to each other, but they're not giving us that. So to make this true, as long as you had equal to each other was in there, this would be an acceptable answer, and this would be an acceptable answer. Keeping in mind that when you have this symbol or this symbol, only part of it needs to be true for that statement to be true. Okay, this will wrap up our first lesson. Shortly we'll go on to lesson 1.2.